Assalamu alaikum friends, welcome to day 8 of AFM revision crash course. Today we are going to cover Black-Scholes option pricing model. So we are going to go through the past exam history, then we are going to go through the black option pricing model, how do we use it in a question. Delta hedge, a small part is for delta hedge, okay, it's not very detailed, it's briefly you have to know about delta hedge. Real options in investment appraisal. So let's start with the past exam history. If you see the real options and Black-Scholes option calculations almost comes in question number 1. Okay, it is mostly linked with your investment appraisal question. For example, when you had to calculate net present value, they might give you a scenario that your net present value is negative. First, you have to calculate net present value, which is negative, and then using the option, when you add the value of the option with that, the call option, the value increases and hence you accept the project. So basically, this is the scenario. That's why you see real options are in question 1 mostly. And then delta or Greeks we have in question 4 is not it's outdated because earlier when AFM was P4 there was four questions, so we don't have four questions now, we only have 3 questions. So let us go to the recent papers and see that it came once and twice, okay, as question 1 and 2. Let us go to the Black-Scholes option pricing model. Now how do you value options? There are 5 variables that you need to know through which we measure our options. One is known as PA. What is PA? PA is the price of the underlying instrument. For example, share price. Okay. The current share price. It will be given to you. PE. Before we go to PE, ND1. What is ND1? The probability of D1. Right? We had to calculate a D1 variable there. If you remember the formula of Black-Scholes option pricing model, we have to find the probability of it using normal distribution table. So definition and all is not needed, but just know that variables you have to calculate. These variables. Okay, they will be given to you. Some are given, some you have to calculate. For example, D1, D2, ND1, ND2, these things you have to calculate. But PA, PE, R, T, standard deviation, time, rate, this will be given. The next is PE, that is your exercise price. Then we have R is your risk-free interest rate. Okay, and we use it as a decimal number. For example, if you're having a 12% interest rate, you are writing it as 0.12. Then time, time to expiry of the option. It could be 6 months, it could be 3 months. If it is 6 months, remember time. Let's say they are giving us 3 months. We are not writing 3 in our calculation. We have to write it in terms of decimal. That means 3 over 12, which is 0.25. So if it's 6 months, time will be 0.5. If it's 3 months, time will be 0.25. Okay. Then we have S. S is your standard deviation. Sometimes they might give you variance instead of standard deviation. So you just have to find the square root of that variance to find the standard deviation, because you cannot use the variance in the formula. You have to first convert it into standard deviation. Okay, so the formula of standard deviation is the square root of variance. Okay, or they might use this word such as volatility. They might not write the standard deviation, they might write volatility. Okay, then so this is the formula. The main formula, the option price formula is C. C means call option. We are valuing a call option here. Call European option, which is PA into ND1. PA is your PA is your underlying price. For example, share price. It will be given to you. ND1 you have to find out. Minus PE is the exercise price is given to you. ND2 you have to find out. And if you see at the end there is one small figure, that is E to the power minus RT. Okay, it's fixed. There is a E in your calculator. If you see, you have to press that and to the power minus R into T. When you're putting it minus R into T, make sure that you're putting a bracket over there. Okay, I have definitely demonstrated how to use it through our calculation. Okay, we'll be doing a calculation in quite some few moments. Now D1 you calculate ln is your logarithm of PA over PE. So when you're putting it in the calculator, you have to put the log and you have to put bracket. Underlying price divided by exercise price plus R is your risk-free rate, plus 0.5. 0.5 is fixed into S, that is your standard deviation squared, and it will be in the bracket, and then you multiply by time. Okay, then you divide by s to the square root of t, that means standard deviation into square root of time. And after that you have to find d2. Remember, you first have to find d1, because if you don't find d1 you cannot find d2. Your d2 is dependent on d1. If you see the formula of d2 is d1 minus s to the power t, sorry, s into square root of t. So the pull call parity relationship, this is for call. Okay, the first formula that is given. Second formula is for put option. If it's a put, you can use the call option, value at the call option to find the put option, because there's a relationship between these two, pull and call. You don't have to find out any new thing. Okay, already you have found out. For example, put option is call option, whatever the value you get, minus PA, that is your share price, plus exercise price into e to the power minus RT. Okay, that last part you must have already done it when you are calculating the call option. So you don't have to find anything new. Now let us go to the calculation of Black-Scholes option pricing model, and I will be demonstrating how to use the normal standard distribution table. So here you go. Let me explain you how to use Black-Scholes option pricing model in a question, and also how to use the standard distribution table to find the probabilities for ND1 and ND2. So the question is, this is the question. The current share price, you'll be given the current share price, which is 3.5. And remember, Black-Scholes option pricing model, you can use it to value European call option. European means when you are exercising the option at the date of the expiry. Only one date is there. American call option means when you can exercise the option. During that call option, you can exercise at any time. Okay. But the difference, what is European option, American option, will not be asked in the exam. The only important thing that will be asked is the calculation of the value of the option. Okay, call option. And if it's a put option, there is another formula to calculate put option, which we saw previously. But this question is just for call option. Okay, and the exercise price is 3.3. 3 months to run. That means this is the time that they have given you. So the time, share price, exercise price are given. Now we need 2 more variables. We need 5 variables to answer Black-Scholes option pricing model. That is risk-free rate is another one, and your standard deviation. Here they have given you the variance. So remember, you have to first convert the variance into standard deviation and use it. You cannot use variance. Okay, and here we have the table of the standard normal distribution table, which you need for your Black-Scholes option pricing model to calculate ND1 and ND2. Now, how do you start when you are given a Black-Scholes option pricing model question in the exam? You first start by finding D1. Okay, and then you have to find D2. Then you have to find ND1. Then you have to find ND2. Okay, you have to find these 4 variables first. So let's start finding D1. Okay, the formula is there. It's there in your formula sheet is there on your CV platform. You will have access to it. So there the formula is given to you. Okay, but let me write the formula again. So the formula is D1 equals to ln, that is logarithm of PA, that is the share price, divided by PE, that is the exercise price, plus R, that is the rate, interest rate, plus 0.5 S square, that is standard deviation, you are squaring it. Okay, into T, that is time. Divide the whole thing by S over T, standard deviation into square root of T, time. Okay, so when you're writing this, it will be D1. Obviously you don't have to write the formula because formula is already there, and this is a CB platform, so you can just enter the number. Okay, logarithm, it is PA. What is your PA? Make sure that you first write all your variables here, PA, PE, your R, your S, your D. Okay, so your PA is the share price, which is 3.5. Your PE is the exercise price, which is 3.3. R is the interest rate, which is uh, 8%. So it will be 0.08. S, standard deviation, you are not given the standard deviation, you are given the variance. You have to find the standard deviation. How are you going to find the standard deviation? It is simply the square root of variance. Square root of variance is standard deviation. So square root of 12%, that means 0.12 is the standard deviation. Okay, then time is 3 months. Remember, we cannot write 3 for 3 months, we have to write it in decimal. That means 3 over 12. So if you are writing it in decimal, it will be how much? 0.25. You have to write time like this in decimal. Okay, and make sure that you know to use your calculator for this, and or you can use your Excel. Okay, one of it. But for following the functions like logarithm and all, calculator is better. Okay, your calculator which is the only CB platform, not your manual calculator. Okay, because sometimes they might not allow you to use a manual calculator. You have to know how to use the calculator on the screen given. So PA, so PA is 3.5, PE is 3.3, close bracket. Make sure when you're writing this in the calculator, you have to put bracket. Okay, you have to know the appropriate places to put bracket. If you are not able to do it in one go, do step by step. For example, this you can find out first and keep it ready somewhere in your scratchpad or Excel. You can write it somewhere, because you are not having any paper, you have to write it on your computer, on your screen. So make sure that you save it somewhere, the answer, because the answers will not be saved on your calculator. Okay, then the next one is this part. Let me highlight it for you. So this is the second part which you can do, and this is the first part you can do. Let me number it. 1. Okay, second, and this one is number 3. So you can do this calculation in 3 stages and finally get the answer. 1 plus 2 divided by 3. Okay, and find D1. So R is, sorry, I have to use a red color. Yes, R is 0.08 plus 0.5 into, let me keep it as a square root of 0.12 only. Okay, you can find out the actual answer if you want. If you don't want to keep it in square root, it will be 0.346 something. Okay, but anyway, let's square it out. Even if you square it, it will be 0.12 only. Okay, and now you multiply this by t means 0.25. Now divide the whole thing, the third step, s over t. So s is square root of 0.12 into time is 0.25. You can keep it like this also, or you can find out the square root of 0.12 into 3 decimal places. You can write it. So now the next step, d1, the amount that I'm getting from the first, okay, that is logarithm of PA over PE is 0.059 plus, in the bracket I'm getting this bracket, okay, 0.14 into 0.25 divide by 0.173. Okay, so D1 will be 0.094 divided by 0.173 equal to 0.54. Now this is your D1, and make sure whenever you're writing D1 and D2, it should always be round up to 2 decimal places. 2 decimal places. I will show you later, because when you use the normal standard normal distribution table, more than 2 figure you cannot find out. You have to write it in 2 decimal places only. Even if it is 0.537, 0.54. Okay, not 1 decimal place, not 3 decimal place, 2 decimal place. Okay, let me write it. 2 decimal place fixed. for both D1 and D2. Make sure that you remember this. So now D1 is found 0.54, keep it. Now let us go to D2. First find both D1 and D2. So formula for D2 is D1 minus S to the power T. So D1 we know it is 0.54, okay, 0.54 minus S is 0.12. I'm keeping it in the square root only. So hence, if you break it down further, it will be 0.54. The answer from square root of 0.12 into square root of 0.25 is 0.17. And hence, sorry, just okay, 0.17 equal to 0.37. Did you see this is also in two decimal places? This is also in two decimal places. 0.54 and 0.37. Now, go to the next step. The first step is D1 and D2. Step 2. ND1 and ND2. Okay. Here at this stage you have to use a normal distribution table. How are you going to find out? Keep it like this. N for D1, okay? For D1 it is 0.54. For D2 it is 0.37. Okay, equal to. Now we'll go and use the table. So it is 0.54. How do you read? First I'm finding for D1, which is 0.54. So when you're putting in the table, first you have to start from this column, this side. Okay, first it is vertical, then it is horizontal. I hope that you have understood. Okay, it is this side first, this column, then we are going like this. So first it is 0.54, so you have to find 0.5 from here, which is this. After this you have to find 0.54, that means the second decimal place is 4. So out of this, the second decimal place is this one. You see, you add 0.5 with 0.04, it will be 0.54. You simply have to add this two. It makes up to 0.54. First decimal place is 5. To get the first decimal place, you have to use this. Okay, downwards like this. And to use the second decimal place, you have to go like this across, which is 4. So 0.5 and 4, 0.54. Okay. So which column is getting 0.5? First you go like this across and stop where it is in line with this. You see this one, this is the amount, 0.2054. Let me highlight it, because at this it is 0.5 as well as 0.04. So this is how you use the standard normal distribution table. Same way for 0.37 also for D2. Let us find that also. D2, which is 0.37. So 0.3 is this and 0.07 is this. So 0.037 will be this one. 0.37, sorry, 0.37 is 0.1443. These are the two probabilities that you have to use. Now you have to do another step. That's not enough. After you found out the probability, if you see the probabilities are both in positive. Okay, if you see this is also positive, this is also a positive figure. Please pay attention to this, is very important for you, because if it's a negative, calculation is different. So because this is positive, when it's positive, D1 and D2, you add whatever the probabilities you get from the normal distribution table with 0.5. So it will be 0.5, 0.5, both are positive in this case, so you are adding. For D1 we got 0.2054. You will get this into 4 decimal places. Okay, this is from the normal distribution table. And 0.1443. Hence your ND1 is, this is the final answer. It will always be more than 0.5. The simplest way to remember this is this, if it's positive, because you're adding with 0.5. 0.6443. Okay, so later on you have to use this number. If it was negative, let's say this was negative 0.37, let's assume you're getting a minus 0.37. What should you do? Then you have to deduct that number. Okay, you have to deduct that number from 0.5. 0.5 minus that number. So in this case it will be, okay, this is just an assumption. Okay, 0.5 minus this amount. It will become minus. Okay, so the number will be less than 0.5. Okay, it will be something, whatever it is, some number. But if it's negative only, you have to minus it from 0.5. If it's positive, add with 0.5. Okay, so plus, add 0.5, negative, minus 0.5. That's it. That's the difference you have to remember. Okay, let me cut this, otherwise you will get confused. What is step 3? Step 3. Use the Black-Scholes option pricing model finally, right? So what is it? If you see the formula up here again, it is, the formula is not given here, but because I wrote the formula for D1 and D2. Okay, but anyway, the formula is that you have to multiply the PA with ND1. So PA is, your share price is 3.5, multiply by ND1, which is this amount, 0.7054. If you see the formula, you will understand this. It is PA into ND1 minus PAE, that is PE, your exercise price, which is 3.3. E, there is an E there. Remember, E is there. So E to the power, okay, minus R, which is 0.08. It's minus only. This is minus, okay. From the formula, it is minus. Not that R is negative. R, that is your interest rate, into time, RT. Time is 0.25. Okay, this is to the power. E to the power minus 0.08 into 0.25. Make sure that you know this. You cannot go wrong in this part, okay. Most of the students go wrong in this part when they are taking powers and all. So if you're getting confused, if you're not getting the answer, don't do it in one go. I would suggest do it in step by step. And you have to multiply this by, you have to multiply this by what? ND2. ND2, this one. 0.6443. And finally, what you are getting is, from this part you are getting 2.47. From this part you are getting 2.08. And 0.39. This is your answer. Value of the call is 0.39. Okay, if you are having a put option, okay, there is a formula for that also. So you have to use this call option value and find the value of the put. For put, you don't have to do any additional thing, because PAE we know, we know the exercise price, we know the share price, we know the ND1, ND2, everything is found out before when we were calculating call option. So it does not matter whether call or put option. Steps are similar. The only thing is, for put option, one extra line is included. Okay, but you have to use the value of the call option to find the put option. That's why it's known as call put parity. There's a relationship between these two. You cannot find out the value of the put option without finding the call option. So whatever the case is, whether call or put, both the condition, you have to find the value of the call option. Then only you can reach to the put option. So in the exam, you first have to identify whether it's a call option or a put option. Okay, to use the Black-Scholes option pricing model to value that option. Now let us move on to the limitations of the Black-Scholes model. Number 1, it assumes that no dividends are paid in the period of option. Why dividends? Because we are taking a share price. So in the share price, we pay dividends also, but they are assuming that that share price is, from that share price no dividends are paid. Hence your share price is not affected. You will be having the same share price throughout, because no dividends are paid according to the model. So these are some limitations because of that. Because in reality, you do pay dividends, and hence your share price gets affected during the period of that option. Let's say you have taken an option for 3 months or 6 months. So during that period, your share price might change. But in the Black-Scholes option pricing model, that PA that you are putting, we are assuming it is the same PA. Same share price is only remain for the 3 months during the period of the option. Limitation number 2. You can only apply this to the European call option. European means when you can exercise the option at a point in time, at the expiry date. But in reality, you might exercise that option anytime during the time of the option, during the duration of the option. But this Black-Scholes option pricing model only assumes that we are exercising the option at the date of the expiry. Hence, you can only value European call option. Okay, if the above, that means the first limitations regarding dividends is true, then you can value US call option also because share price will not change. Okay, but in the exam they will be giving you European options only. They will not give you an American option to value, because if they give you American options, you cannot value it using Black-Scholes option pricing model. Then what's the point of giving it a Black-Scholes option pricing model, right? Next, third limitation is interest rate. We assume that the interest rate, the risk-free interest rate is known first of all, and it is constant. But we know in reality it's not true. It changes and it's not known with certainty. Coming to this fourth one. Fourth one is also same, but this is related to standard deviation. We know standard deviation changes, but for this model we are assuming it is constant and we know it. And the last limitation is we are not taking into account any transaction cost or tax effect because of the buying or the selling option, right? Or even the underlying security. When we buy or sell that share or the option, there are some transaction cost to it. There are some tax effect to that, which we are not taking into account. Now let us move to the delta hedge. What is delta hedge? A small portion of this part came in the exam. I don't remember exactly the past paper, or one of the past paper I saw delta hedge, where you were supposed to calculate the number of options that you need to buy or sell. So delta hedges, delta means change. Okay, how sensitive your price of your option is to the changes in the variables. There are 5 variables, remember, to value the option. One is exercise price, your underlying share price, your risk-free rate, standard deviation, time. So if any of these changes, option price will change. Hence, that change is known as delta. Okay, so a delta hedge is an option position which, when added to a portfolio, causes the portfolio to be delta neutral. Okay, all those things is not supposed, you don't have to know the definition and all. Mostly when they ask about delta hedge and all, they will be asking a calculation. So this is the formula that you need to know for delta hedging. This is the only formula that you need to know for delta hedge. Change in the price of option divided by change in the price of underlying security. So that change in the price of option is caused by various reasons. We know that, right? When we calculated D1, we took the impact of everything. Hence, so number of call options to sell. Usually in the exam, they will be asking you two things. One is number of call options to sell, or either number of shares to hold. If it is number of call options to sell, the formula is number of shares held divided by ND1. That means you have to calculate first ND1, and that will be divided by the number of shares held. Number two, they might ask you the number of shares to be held. Then it is number of call options that is sold into ND1. Okay, so for the second one, if you see, you need the first one. To know the number of shares to hold, you should know how many call options you have to sell using the first method, number of shares held divided by ND1, and then you have to multiply it by ND1 to find the number of shares to hold. Okay, make sure that you do the questions. The questions are not too many. I think only one or two questions are there on delta hedge. So make sure that you go through those questions, and mostly it's around for 5 or 6 marks. Okay. Now we are coming to the real option. The main thing is real option. This is what you will be given in the exam if with your calculation of net present value, investment appraisal. Okay, real options. There are 4 types of real options. Option to expand, option to delay, option to switch, option to abandon. Okay. In the exam, it could be any real option which is given to you. Maybe you have an option to expand after 2 years the project. Maybe you have an option to delay. Maybe you have an option to abandon the project. So it could be any option. In that case, you have to use the Black-Scholes option pricing model to value. Okay, so real option, the benefit is the real reason why we are taking real option to value investment appraisal is not only net present value. Why? Because it attempts to classify and value flexibility. When we are calculating net present value, we don't calculate that flexibility. We assume they are going with the investment. If it's a positive net present value, they will go with the investment. But in reality, we know that they might not take the project. Right? They have that flexibility is there. They might go ahead with the project or not. So that's why that flexibility, that impact of that flexibility is added with your net present value through real options. So you value real options and add it with your net present value. Okay. And there are options on real physical assets. Okay, this, don't get confused real options with the options that you are going to study in the risk management. Okay, exchange risk management and interest rate risk management, those options are different. Those are financial options. Those are hedging instruments we are using to hedge foreign currency risk and interest rate risk. So don't get confused between these two type of options. This is real options. Okay, when it's real option, we are using the Black-Scholes option pricing model only, the way we have used for options. Okay, so this will be added with your conventional net present value, such that the formula is also given. Your net present value plus value of real option will give you the strategic net present value. So when you are giving recommendations whether you have to go ahead with the project or not, remember to add the value of the real options with the net present value. Even if your net present value is negative, don't say, you can say okay, you are going to reject the project based on the negative net present value, but after you add the value of the real option, it becomes positive, then you have to say you can go ahead with the project because the real option is worthwhile. Hence, you are getting a positive net present value. So you have to comment based on your strategic net present value after adding the value of real options, whether you are going to accept or reject the project. Then Black-Scholes option pricing model. Okay, this model you can use to value real option also in the exam. You should use this. But in reality, we know that real option is very hard. Okay, you cannot measure it. It's very hard to quantify that. How will you know what is the value of the option to expand? It's very hard. But for your exam purpose, you can use the Black-Scholes option pricing model, the same method that I have covered just few minutes back. Okay. And for real option, PE is, that is your exercise price. Okay, PE is, okay, this is real option, so you will not have an exercise price. So for real option, PE is the capital investment that is required. It will be given to you in the scenario. They will be telling you that this is the capital investment that is required for this project. So that capital investment only is your PE. Okay, you will replace this with your exercise price under real options, and PA is the value of the future cash flows from the project. Okay, so this two only changes when it comes to real option. Rest everything remains same: standard deviation, time, and risk. And for your further reading, on your ACCA website there are two technical articles on this real options. Okay, where they have some worked examples on how to value real options. So make sure that you go through this, because I am expecting, this is from my that's what my gut feeling and my experience is saying. Okay, that you are going to get a real option this time in your exam for September sitting, because long time it didn't come, so I'm expecting that this will come up this time. So yeah, so that's it for today. Tomorrow we are going to come to a very important topic and very interesting topic and most awaited topic by many, which is risk management. Yes, introduction to risk management. We are not going to go through hedging instruments and all tomorrow. It will be on day 9, but tomorrow we'll be covering all the types of risk: political risk, financial risk, value add risk, all those things. Okay, it's mostly like theory parts and all I'm going to cover more than the calculation part. So see you tomorrow and take care.